In Learning Assessment 7.5, problem statement is that the switch in the network below closes at t equals 0. Find V0 of t for t greater than 0. And we're going to utilize our problem-solving strategy entitled Using the Step-by-Step Approach. So there's our circuit. And if we look at our problem-solving strategy, step 1 says we know the form of the solution is V0 of t is equal to K1 plus K2 e to the minus t over tau. Our task is to find values for K1, K2, and tau. And if you refer back to our problem-solving strategy, it says next to draw the circuit at t equals 0 minus, and we're going to assume steady state, so we're going to replace this capacitor with an open circuit. Okay, so here's our circuit for step 2. We have replaced the capacitor with an open circuit. Now let's look at this circuit, and what we want to do is we want to find this voltage. So if we look, there's 3 amps here. We know there's 0 here, so that says that current has to be 3 amps. Okay, so then VA prime then is 3 times 4, which is 12. Okay, so we applied Kirchhoff's current law. At that node, there's 3 amps entering here, 0 here, so there has to be 3 amps flowing down through this resistor. So now we have VA prime, and now we can simply go around this loop to find VC0 minus. So VC0 minus, okay, to VA prime then, this is going to be 24 plus 24 for here, and then plus 12, and that's 60 volts. Okay, so now we've completed step 2. Now step 3 says draw the circuit at t equals 0 plus, and open and replace the capacitor with a voltage source equal to 60. But if you'll note from our circuit, we're essentially finding the voltage across the capacitor. So I'm not going to draw the circuit. I'm just going to go in and say, well, for step 3, then we know that at t equals 0 plus, that this holds, and we know that's 60 volts. So there's no need of drawing the circuit here, because our voltage is right across the capacitor, and we know by continuity of voltage for the capacitor that VC0 minus equals VC0 plus. So our next step in our problem-solving strategy then is to draw the circuit at t equal infinity. Now we're going to assume that the switch is closed. The capacitor again is an open circuit. So now here is our circuit to analyze. And if we think about it for a second, we really, let's focus on this connection here. We've basically shorted out that source. So I could redraw this circuit as follows. Now let's look at it for a second, and we know by this open circuit that this is 0, and as a result, if we apply Kirchhoff's current law here, it turns out that both of these currents are 0 as well. And if you say, well, how would you know that? Well, let's say we had defined a loop current here, and we would have, for instance, 4 times that current plus 4 times that current 0, and the only way that can be true is if that current's 0. So now this tells us that VA double prime is 0. This source is 0. So it tells us that V0 of infinity is equal to VC of infinity is equal to 24 volts. So that completes step 4. Now we move on to step 5. Says find the time constant. Now what's different about this learning assessment as compared to the previous one is we have a dependent source. Now remember, our time constant is R Thevenin times C, so now we have to find R Thevenin. And remember, with a dependent source, that means you have to calculate the open circuit voltage and the short circuit current. So let's look at how to calculate the open circuit voltage and the short circuit current. Now, again, remember, our time constant is R Thevenin C. We got to find the Thevenin resistance, so that's going to mean that we need to calculate the open circuit voltage and the short circuit current. Now that circuit at the top should look very familiar because that's a circuit we just solved here. So we can tell from this that the open circuit voltage is 24 volts. Now we need to work on that bottom circuit, and let's go in, for instance, and combine those two resistors in parallel. And when we do that, here's the resulting circuit. And now we've got a single loop circuit, and if we just go in and apply KVL to that loop, we'll have 2 I short circuit minus 24 minus 2 VA triple prime equal to 0. And if we look at the circuit, we can see that VA triple prime is minus 2 I short circuit. So we have 2 I short circuit minus 24 minus 2 times minus 2 I short circuit equal to 0. This is going to give us I short circuit equal to 24, or I short circuit is 4 amps. So now if we go to calculate R Thevenin, we know R Thevenin is V open circuit over I short circuit. So we have 24 over 4, and that tells us that R Thevenin is 6 ohms. And now the time constant, tau, is R Thevenin C. So we have 6 times 2, the time constant is 12 seconds. The last step of our problem solving strategy says, well, we know this is the solution, now let's plug in the values. So we have V0 of t, then is 24 plus 60 minus 24, e to the minus t over 12 volts. So that says that V0 of t then is 24 plus 36, e to the minus t over 12 volts.